Hello. In this video, I thought that we would derive the derivative for some function f of x is equal to, I'm just going to call it c. The idea is that it's some constant, some arbitrary base here to the power x. So that could be 2 to the x, that could be 3 to the x, that could be, negative 6 to the x, whatever. The idea is that we have some sort of exponential function here, and we want to find f prime of x. It's our question mark. So, and this can be derived using the definition of derivatives, but that's not what I'm going to be doing in this video. In this video, I'm going to be using some derivatives that we're already somewhat familiar with, and the chain rule regarding the natural log and e to the x functions to find what the derivative of this function is. So to start with that, I'm going to redefine this function. I'm going to say that f of x, it's the same function, but I'm just going to put it into kind of different terms. I'm going to say that f of x is the same as e to the natural log of c to the x, right? E to whatever power e goes to so that it becomes c to the x, right? The e and the natural log would cancel out, but we're just going to have it in this form because that e there is something we're a little bit familiar with. And this, because of exponent properties, can be rewritten as e to the x natural log of c. Hopefully you're with me, but that's just using exponent rules and redefining our function a little bit, but it's still the same function. So now if you recall those special functions that I gave the derivatives of, you should know that the derivative with respect to x of the function e to the x is equal to e to the x. That's one of the very fascinating things about it, and one way that you can define the constant e. Also, the derivative with respect to x of the natural log of x is equal to 1 over x. That's just another thing that's good to know. But what's important is that we look at this one for now. So now that we have things in this form, we can use the chain rule. I'm going to bring up orange. We can use a chain rule because we have an outer function and an inner function. Notice we have e to the natural log of c times x. And this is all a part of this inner function. Natural log of c is a constant, so that's just some constant times x, right? But then our outer function is e to the x. So to do the chain rule, we know that the derivative with respect to x of e to the natural log of c times x is going to be equal to, well, we take the derivative of the outside, right? The outside function is e to the x, and then we plug in for x the inner function. So that's the first step. So we have e to the, and I'm just going to add it right back up here, right? Because it's the same thing, natural log of c times x. But then we multiply by the derivative of the inner function. And I pulled this up here because it's kind of interesting, but it's not actually going to be used here because since natural log of c is just a constant, this inner function is really just linear. So the derivative is going to be the slope of that line, which is going to be natural log of c. So there's another way we can simplify this. If we put things back into other terms, if we say, hey, wait a minute, that's the same as e to the, not x times natural log of c, but natural log of c to the x power, because those are the same thing based on exponent rules, times natural log of c. We know that the e and natural log cancel out, and we are left with c to the x times the natural log of c. And that's a kind of interesting result, so I'm gonna bring this over here. Let's put things back into white, just so that we can separate out the information. So we know that given f of x is equal to c to the x, f prime of x is equal to And I'm going to rephrase this a little bit just to get the constant on the left. It's going to be the natural log of c times c to the x. Hopefully this helped with your understanding of the chain rule and how you can manipulate functions to make taking their derivatives a little bit easier, and I'll see you in the next video.